Let's explore text processing with awk, a powerful tool designed for extracting and manipulating structured data. Awk is also known as a pattern scanning and processing language. The name awk comes from the initials of its creators, Aho, Weinberger, and Kernighan. Awk is a pattern scanning and text processing language designed for use in one-liners and small programs. It processes data line by line and automatically splits each line into fields. Common uses of awk are to extract specific columns from structured data, to transform data from one format to another, to generate formatted reports from raw data, and to perform calculations on data fields. The basic syntax of an awk command is as follows: awk, followed by the pattern in single quotes, then the action in curly braces, again in single quotes, and finally the file name. For example, to print all lines containing the word error, the command is awk/error/print logfile.txt. As another example, to print the first field of each line, the command is awk print $1 data.txt. Awk processes each line of input, checking if it matches the pattern. If a match is found, or if no pattern is specified, it executes the action. Fields are automatically split and accessed using $1, $2, and so on. Awk has several built-in variables that make text processing easier. The first group of variables is field variables. $0 represents the entire current line. $1, $2, and so on represent the first, second, and subsequent fields. NF represents the number of fields in the current line, and $NF represents the last field in the line. The second group of variables is record variables. NR represents the current record, which is the line number. FNR represents the record number in the current file. FS represents the field separator, which defaults to a space. RS represents the record separator, which defaults to a new line. Awk excels at extracting, filtering, and transforming structured data. It can also perform calculations on fields and generate summary reports. For example, to print specific columns such as fields 1 and 3 from a file named data.txt, the command is awk print $1, $3 data.txt. To sum the values in the third column, the command is awk sum plus equals $3 nd print sum data.txt. To filter rows where field 2 is greater than 100, the command is awk $2 greater than 100 print data.txt. Awk supports powerful pattern matching with regular expressions. For example, to match lines containing the word error in a file named logfile.txt, the command is awk/error/print logfile.txt. To match lines starting with debug in the same file, the command is awk/debug/print logfile.txt. To match lines with numbers in field 3 of a file named data.txt, the command is awk$3tilde/0-9+/print data.txt. There are three primary pattern matching operators in awk: /pattern/ matches lines containing the pattern, ~pattern/ specifies that a field matches the pattern, and !~ pattern/ specifies that a field does not match the pattern. Awk supports programming constructs like if-else statements, loops, and functions. This makes it powerful for complex text processing tasks that require decision-making logic based on the content of each line. For example, the command shown implements an if-else statement to evaluate scores in a file named scores.txt. The command is awk if $3 greater than 90, print $1, excellent, else if $3 greater than 70, print $1, good, else print $1, average, scores.txt. Awk includes special begin and end blocks that perform actions before and after processing the input data. Begin is useful for initializing variables and printing headers. END is useful for printing summary statistics and report footers. For example, the command shown uses begin to initialize its sum and account variable, then processes the file data.txt, summing the values in field 3 and incrementing the count for each line. Finally, the END block prints the average of the values. The command is awk begin print processing file. Sum equals 0 count equals 0, sum plus equals $3 count plus ND. Print average. Sum divided by count, data.txt. awk is commonly used in system administration, log analysis, and data transformation tasks. It can process output from other commands through pipes, making it a versatile tool in command line workflows. For example, to calculate the total disk usage by user, you can use the command dfh pipeawk !/filesystem/ print $1 to $5. To extract IP addresses from a log file, you can use the command awk for I equals 1, I less than or equals nf, I++. If $I tilde / bracket 0-9 plus backslash, bracket 0-9 plus backslash, bracket 0-9 plus backslash, bracket 0-9 plus $/, print $I, access.log. To format CSV data as an HTML table, you can use the command awk f, print table row table data, $1 table data, $2 table data table row, data.csv. In summary, awk is a powerful tool for text processing, offering powerful pattern matching with regular expressions, automatic field splitting for structured data, built-in variables for record and field handling, and programming constructs for complex processing. It is commonly used for log file analysis and filtering, data extraction and transformation, generating reports from structured data, and system administration tasks. To learn more, you can explore the GNU awk documentation, the book The Awk Programming Language, and Linux command line tools. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.